Hello students, I am Narinder Kaur, Assistant Professor, PG Department of Mathematics from Khalsa College, Patiala. Here I am in front of you to teach the subject Abstract Algebra of BSc third year. Abstract Algebra mainly contains group theory and ring theory. Now here we shall start with group theory. Now what is the definition of group? Let G be a non-empty set together with a binary operation star defined on it. Firstly, we shall take a non-empty set which is generally denoted by G, and we shall take a binary operation star which is defined on this non-empty set G. Now if this algebraic structure G star satisfies these four axioms, then it will become group, otherwise not. Now, what are these four axioms? First is A star B belongs to G for all A B belongs to G. Whenever we take two elements of this non-empty set G, then A star B, A operated B should belong to G. This property is known as closure property. This is known as closure property. Now, second is A star B star C should be equal to A star B star C. That means if we operate A star B firstly and then operate C, or we should operate B star C firstly and then operate A star B star C, then answer will be same. And you all know that this property is known as associative property. This is known as associative property. Now third is, there exists an element E belongs to G. There must exist an element E belongs to G such that E star A is equal to A star E for all A belongs to G. That means for every element A belongs to G, we must find an element E in this non-empty set G such that it satisfies this property. Here easily you can see that E is playing the role of identity. What is identity? It is known as identity. Why? Because it does not change the identity of A. A will remain A when it is operated with E. That's why it is known as identity. This property is known as existence of identity. Existence of identity element. This E is identity element. Now, fourth property is, for all A belongs to G, for every element A belongs to G, there must exist some another element in G itself such that A star B is equal to E is equal to B star A. That is, whenever A is operated with this element B, then answer should be identity. And we all know that when answer is identity when an element is operated with its inverse. That means this B will play the role of inverse. Then B is called the inverse of A and is denoted by A inverse also. This property is known as existence of inverse. So if all these four axioms are satisfied on this algebraic structure G star, then this G star will become a group. What are the four axioms? First one is closure property, second one is associative property, third one is existence of identity element, and fourth one is existence of inverse. Now next is finite and infinite groups. Now what is a finite or infinite group? In the group G star, whenever G is finite, group is finite. In this, if this group is finite, if this non-empty set G is finite, group will be finite. If this set is infinite, group will be infinite. Now next is order of a group. What is order of a group? In a group G star, the number of distinct elements in G, if there are n distinct elements in G, then order of this group will be equal to n. We generally denote by order of G is equal to n, or we can write like this also, order of G is equal to n. So what is the order? Order is the number of distinct elements in this non-empty set G which forms the group. Next is abelian and non-abelian groups. Now we have studied here that to form a group, 4 axioms should be satisfied. First one is closure, then associative, then is existence of identity element, and then is existence of inverse. Now to form an abelian group, one additional property should be there. A group will be abelian if it satisfies this property: A star B is equal to B star A for all A belongs to G. This property is known as commutative property. So instead of abelian we can say commutative group also. If this property is satisfied, then group will be known as commutative group or abelian group. If this property is not satisfied, that means if A star B is not equal to B star A for all A belongs to G, then the group will not be abelian, or we can say it is non-commutative. Next is groupoid, semi-group and monoid. Very easy concept. Now, to form a group, G star must satisfy all these 4 properties. Now suppose if we know that only first property, that is closure property, is satisfied, then it will form groupoid. Means to form a groupoid, the definition will be till first point only. That means an algebraic structure G star will form a groupoid if A star B belongs to G for all A B belongs to G. Now next is semigroup. What is semigroup? If along with first property, second property is also satisfied. That is, if with closure property, associative property is also satisfied, then we shall call this algebraic structure as semigroup. Third one is monoid. Now what is monoid? If along with these 2 properties, third property is also satisfied, that means this algebraic structure G star satisfies the closure property, associative property, existence of identity element, then this algebraic structure G star will be known as monoid. And we all know that if all the 4 properties are satisfied, then it will form a group. So clearly, if only first property is satisfied, then it is groupoid. If first 2 properties are satisfied, then it is semigroup. If first 3 properties are satisfied, then it will be monoid. And if all the 4 properties are satisfied, then it will form a group. Now let's discuss an example. The set of natural numbers with binary operation, addition, usual addition, is semigroup but not a monoid. Now firstly we shall discuss how it is a semigroup. Let's take any 2 natural numbers. We shall check the properties, which property is satisfied and which one is not satisfied. Let's take 2 natural numbers, and we all know that addition of, because here operation is addition. Addition of 2 natural numbers, there is also a natural number. That means closure property is satisfied. Closure property is satisfied. Now let's take second property. If we add A and B and then add C, or we add B and C firstly and then add A to it, then we know that answer will be same. Why? Because addition of natural numbers is associative. So associative property is also satisfied. So first 2 properties are satisfied. That means it becomes semigroup. It is semigroup. Now to become a monoid, it must satisfy the third property. Now to satisfy or dissatisfy the third property, what we have to do? We have to find the existence of identity element. Whether there exists an identity element or does not exist. Now we know that in addition, what is the identity? Identity is something that we should add in A and answer should be A. It is something like this. What should be here? Here should be 0. because a plus 0 can be a and nothing else can be here. Right? Now, this 0 belongs to n or not? No. This 0 doesn't belong to n. This is not a natural number because natural numbers start from 1. So this doesn't belong to n. That means we doesn't have this identity element. We don't have existence of identity element. That means it cannot be monoid. Now let's take another example. Set of natural numbers with operation multiplication is monoid. Simply, if we multiply two natural numbers, we know that it will be a natural number. And similarly, if we multiply a and b and then multiply c, or we multiply b and c firstly and then multiply a with it, then answer will be same for all natural numbers a, b and c. Right? So these two properties are satisfied. First is satisfied, second is satisfied. Now come to third. What should be multiplied with element a, where a is natural number, so that answer will be a. Clearly, we can multiply a with 1. Only then answer will be a. So what is identity element here? 1 is the identity element here. So there exists, and this 1 belongs to n, this is natural number. So here existence of identity element is there. That means all these three properties are satisfied. So this is monoid. Thank you.